Hi there. In this video, we'll look at multiple choice problem 9 from the AP course description. Here we're given a formula which represents the position of a particle that's moving along a line. And we're supposed to determine for which values of t is the speed of the particle increasing. And choose from these choices. Okay, so just to help you understand what's going on, what I've done is to produce a graph of this function for positive t values. And so we can think of this as telling us that we are 7. We're at position 7. Okay, so picture some point, and we are like 7, let's just say 7 miles north of that point. Okay, and now we're driving up here. Okay, now I'm 100 miles north of that point. Okay, a little more than 100 miles north. And all of a sudden, we're going to turn around and start driving in reverse. And now we're moving back towards this point of origin. Okay, so we're moving backwards here, closer to 100 miles again, and now further away. Okay, now we're 200 miles north, 300 miles north, 400 miles north, etc. Okay. And what I've done here is I've zeroed in on that interesting portion of the graph where the object turns around and starts to move backwards so that we can focus on that. All right. And let's again keep the focus on speed and when the speed is increasing. So right here, during this half-second interval, right here, it takes a half a second to go this far. That's pretty far. During the next half-second interval, not so far. We covered less distance. Wow, during the next half-second interval, not much distance is covered at all. Okay, and in fact, in a sense, we are stopped right there. Okay, just for a moment, we're not changing at all. Now we're headed backwards. So let's just tell a little story here. Let's suppose that we're running to a particular tree. We're going to tag the tree. We're going to turn around and run backwards, tag a different tree, and then we're off to the races. Okay, and that's what's going on. We're going backwards towards the second tree, backwards, 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 tag the tree, turn around and run forwards, 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 forwards. Okay, and in particular, let's again kind of rerun the scenario, but with a focus on when is the speed increasing. Well, definitely not here because the speed is decreasing there. We're moving less and less. So let me just make a note. The speed is decreasing during this time. You're running towards that tree, but you're slowing down, stop, tag the tree. Now you're going in reverse, and you're going this far, farther, farther. Okay, so right here, your speed is increasing. You're going faster, running in reverse, but going faster. All right, then we're approaching this tree, okay, and we're covering not as much distance, stop just for a moment. So right in here, our speed is decreasing again, speed decreasing. And now we're going a little bit far, a little bit farther, farther and faster. So right here, our speed is increasing. Okay, so in terms of the answer we expect that starting at 3 and ending somewhere around here, the speed is increasing in this interval right here, that time interval. And it's increasing again from 5 all the way on up. Okay, so we expect our answer to say that the speed of the object is increasing between t equals 3 and 4 and t larger than 4. Okay, but then the question is, how are you supposed to determine that on your AP Calculus test when you don't have the luxury of just producing this graph right here? How are you supposed to use calculus to come at the answer with no calculator, just you and a pencil? All right, well, for that, we need to use our knowledge of derivatives to compute the derivative of the position function, which is the velocity function. Okay, and that's something we can do by hand, but let's go ahead and interpret what information can be gained from analyzing the velocity graph. Here goes. So the velocity right here is like 90. Here it's 80. Sorry, that's more like 70. Here it's 50. Okay. 40, 30, 20, 10, 0. All right, so what's happening there? The velocity is getting smaller and smaller, and that tells us that the object is slowing down. Slowing down. Okay? And then the velocity becomes negative, which tells us the thing's moving in reverse, and something interesting goes on in between there. But now we're at 0 again, and then 10, 20, 30, 40. Let's see, here's the 50 marker again. And we see that the velocity is again increasing, okay, during this interval here. All right. Now again, I've zeroed in on that interesting part of the graph that's here. So this would be like the velocity is -1, the velocity is -2, -3, -4. The velocity is -5 here. The velocity is -6 right here. Okay, so and again, with these negative velocities, we know that that simply means that the object is moving backwards. But if this is 1 mile per hour backwards, 2 miles per hour, 3 miles per hour, 4, 5, 6, that indicates that the object is in fact speeding up during that time. Now it's moving actually pretty fast, 6 miles an hour, just in the negative direction. All right, so during this interval right here, again, between 3 and 4, as we said earlier, and that does indeed fit with the analysis we did of the position graph, during this time interval between 3 and 4, we expect that the object is speeding up, and the graph of the velocity function tells us that. Okay, now we're over here at -5 again, -4, -3, so it's getting slower, and right now it's stopped. Okay, so this is slowing down, slow. And then we have 1 mile per hour, 2, 3, 4, and on up. And here, it's going faster. Okay, the velocity is increasing there, and the speed is increasing. The thing is moving faster. Okay, and that starts at 5, so we expect that 5 and on up to infinity, the object is increasing its speed. Okay, now that all makes sense, but it really is a lot of mental gymnastics to figure out what's going on. Am I above the x-axis? Am I below? What does that mean? Am I going forwards, backwards, slower, faster? Okay, it really is a little bit complicated. To simplify matters, we'll go to the definition of the speed function, which is simply the absolute value of the velocity. In other words, the speed is just a number. It's not going to bother to tell you the sign like the velocity function does. It'll just tell you the speed is 5 miles per hour. You would not know if that means 5 miles forwards, 5 miles backwards. Okay, and so with the absolute value, we get, instead of this loop below, everything needs to stay positive. Okay, and now it's just very, very simple. Is the graph decreasing? Then the speed is decreasing. Is the graph increasing? Then the speed is increasing. Speed increasing. Graph decreasing, speed decreasing, graph increasing, speed increasing. Okay, and so this is the very simple analysis that will lead us to our conclusion that the speed is increasing across this time interval and this one. Okay, so it remains now to figure out how do we do all of this by hand in under 3 minutes with no calculator on an AP exam. All right, and for that we're going to need to wheel out our derivative skills. So let me go ahead and set my timer and see if I can solve this problem in approximately 3 minutes. Here goes. All right, so speed problem. I know I need to take a derivative, so let me get started on that. 6t squared minus 48t plus 90 plus 0. And I'd like to know when the speed is 0, so I'm going to go ahead and start factoring this, and I notice that each of the values has a common factor of 6. So could move t squared. 6 times 8 gives 48, and 6 times 15 gives 90. Okay, and knowing that I want to find the zeros, I'm going to go ahead and factor the expression, if that's possible. And it looks like we can factor it as follows. Okay, and so from this, I'm learning that the velocity is 0, specifically when t is 3 and when t is 5. So let me go ahead and put that information on a graph. Okay, get this out of the way here. We'll put 0 on the graph, and here's infinity. Okay, I'm just going to pause for a second so I can talk about what it is that I'm thinking as I begin to sketch the graph next. Right here we just have a parabola, and from 6t squared we know that the parabola is going to open up. In other words, we know the end behavior, and so we know that the graph opens up, and so the picture should look something like that. All right, so when I go to do this next step, that's what's in the back of my mind. Okay, timer back on. All right, so in terms of the graph of this function, I know that it goes up like that, goes up like that, and if I want to graph the absolute value of that, okay, which is again the speed function, okay, then rather than dipping down below like that, we're going to mirror it up, okay, and this now tells me the answer that I'm looking for. I know that a parabola is symmetrical, so that must be 4 in between 3 and 5, and I can just see the speed is increasing between 3 and 4, and the speed is increasing from 5 till forever. And so I can pick that answer according to that. So I have when t is between 3 and 4, the speed is increasing. And when t is to the right of 4, the speed is increasing. And let's pop back over to our multiple choice answer. In between 3 and 4, yep. To the right of 5, yep. Looks like answer choice E is a winner. And that took less than 2.5 minutes to determine that. Maybe add in a little bit of time to read and think about the problem and formulate a strategy. But actually executing that strategy took only 2.5 minutes. But there's an awful lot of understanding that goes into that to be able to do that problem in that length of time. Okay, so lastly, let's link this question to the goals for the course and the topic outline. If you look under applications of derivatives, you find that students should be able to interpret the derivative as a rate of change in various applied contexts, including velocity, speed, and acceleration. And in particular with this problem, obviously we were focused on speed. There you have it. Hope this video was helpful to you in your understanding of calculus and in preparing for your AP exam. See you next time.